I'm Anil Kumar. Welcome to my series on absolute functions. Let me thank all my viewers and subscribers for posting most of these questions. On request, I have started organizing the videos now in the form of a website. Soon we'll come up with Global Math Institute website. Now, we already have 12,000 videos with 40,000 subscribers. It is very encouraging to see that most of these videos are watched all over the world. At present, in about 80 countries, the videos are quite popular. I just wrote some names here. Now, thanks a lot for that excellent response, and I hope I can reciprocate with some excellent questions which will help you in your objective of learning. Here are 4 interesting questions based on absolute functions. Question number 1. Sketch graph of the function square root of x squared and describe its characteristics. Question number 2. Express the following inequalities as absolute functions. X is less than or equal to minus 3, union x greater than or equal to 3. X belongs to real numbers, x not equal to 1, and x less than or equal to 3, intersection x greater than or equal to minus 7. So we'll learn some concepts about writing. It's kind of a reverse work. You're given the solution, you need to write the question. And this time, question will be in terms of absolute function. Question number 3. Sketch graph of the function f of x equals to x cubed minus x and write it as a piecewise function. Question number 4 is solve inequality x plus 2 greater than or equal to absolute value of 2x minus 1. I just received one more question. Here is it. Question number 5. You need to solve the inequality which is absolute value of x squared minus 5 is less than or equal to 4. You may treat this as your test question. So I hope after the solution of first 4, question number 5 should not be very difficult for you. It is, however, the most interesting question of this series. So let's begin and solve from question number 1. Question number 1. Sketch graph of f of x equals to square root of x squared and describe its characteristics. Now, square root of x squared is one of my most popular video. Let's have a different approach here to graph this function. So what I will do is that I will just take some values and find what is square root of x squared for those values. So let's take some values for x. Now when x squared is within the square root, then domain is what? Domain is x belongs to real numbers, right? Since it is non-negative, right? So we'll take some values of x which are perfect squares. Well, we could take any value. Well, let's take values like minus 3, minus 2, minus 1, 0, 1, 2, and 3. Now, if you square them, they all become positive, right? That's very important to understand. And square root of those values will be the same number, but positive, right? So with 0 you get 0, with 1 you get 1, with 2 you get 2, with 3 you get 3. But with minus 3 also you get 3. You get the idea, right? So what do you notice here? That f of x equals to square root of x squared is not just x. It is always positive. And so it is absolute value of x. Do you understand? Now that actually gives us another definition of absolute function. So it is absolute value of x. So square root of x squared is absolute value of x. Now this is very important to understand at this stage. Now let's try to graph it. It's always positive. So it is kind of like a straight line. In quadrant 1, it happens to be y equals to x, and in quadrant 2, it will be y equals to minus of x, right? Do you see that? Minus 3 becomes 3, minus 2 becomes 2, minus 1 becomes 1. So that's how you get this particular function. Square root of x squared is same as absolute value of x. Now you can write some characteristics for the function. One of the most important characteristic which I find for this function is that it is an even function. That is to say that f of minus x is equals to f of x. So if I write minus 3, I get 3, and for 3 also we get 3. Do you see that? So f of minus x is same as f of x. For minus 2 the value is 2, for 2 also it is 2, right? Which could easily be seen that it is symmetric about the y-axis, right? So this is a very important property of the function absolute x. Now, from the graph, you could define this function, absolute x, which is equal to square root of x squared, as kind of equal to minus x when x is less than 0, but x when x is greater than or equal to 0. Does make sense, right? And from the graph, it is clear that this function actually is always non-negative, and it is from quadrant 2 to quadrant 1. With one x-intercept and y-intercept at the origin, right? Now another important property of this function is rate of change. As you can see, it is either -1 or +1. So rate of change is something which we should discuss. Rate of change could be what? Very interesting. It is -1 when x is less than 0 and it's +1 when x is greater than 0. Well, what happens at x equals to 0? At x equals to 0, what is the rate of change of this function? Now, rate of change is kind of a slope. So at this point, what you notice is that even the x-axis is tangent, this is tangent, that is tangent, so does not exist. So at x equals to 0, the tangent is not defined, right? So that is another very interesting property of absolute function. So I'll leave it here. You can always add to more properties for this function, including the end behavior. So let me add one, end behavior. So as x approaches minus infinity, y approaches positive infinity. But for x approaching positive infinity, y also approaches positive infinity. Do you see that? So these are few properties which are good to list for the particular function square root of x squared. Let's move on to question number 2 now. Question number 2. Express the following inequalities as absolute functions. Now this question is extremely important, and you will see this in many different forms while working with functions. It's a prerequisite for calculus, right? So the very first one here is when x is less than or equal to -3. Now union means OR. So let me write down OR here, and when x is greater than or equal to 3. On a number line, I could always show it like this. Let's say this is minus 3. It is on the left side of minus 3. Let's say this is plus 3 on the right side of plus 3. Well, this is minus 3, this is plus 3. When we say equal to, we kind of fill this up. Now you see, that is what we have on a number line. You have to express this inequality as an absolute function. Correct? How will you do it? Well, that's not very difficult. What we really see that absolute value of x is actually greater than equal to 3, right? So we could write this as absolute value of x is greater than equal to 3. So that becomes the solution. Clear? Perfect, right? Now let's take up part B. Part B is x belongs to real numbers. Now if I say x belongs to real numbers, what do I mean? I mean the whole number line, right? I mean this. The whole number line. Everything on this number line. How do I express this as an absolute function? Well, one way is to say that absolute value of x is greater than, let's say, any negative number. Let's say minus 1. Now, you know, absolute value is always positive, so that helps. Do you see that? So you could easily do it in this fashion. Correct? I'm actually saving the space for the last question. Let's get to C. So I'll answer C in this part. So we got part A and B, right? Now let's look into the last question, C, which is x is not equal to 1. How do I write this as absolute function? On a number line, what I'm trying to say here is that except for, let's say this is 0, except for 1, that means there is a kind of a hole here, right? Everything else is part of our solution. Do you understand? How do I say that in terms of absolute function? It's kind of tricky. Well, what you could do here is that you could do, if I translate my absolute function here, means normally that vertex is at 0. If I move it to 1, then I could say that absolute value of x minus 1, which is, it has been moved right, is what? At this point it is 0, so if I say is greater than 0, that means I have everything else but 1. Since at 1 it is equal to 0. Do you see that? Do you see that part? So this is the most important and interesting part so far. Now let's look into part D, which is a critical question here, where we are saying that the value of x is less than equal to 3 intersection means and x is greater than equal to minus 7. Now what does that mean? On a number line, it really means that, let's say this is 0 and this is 3 for us, and here we have 7 minus. Now what we have here is x is less than equal to 3. That means from 3 everything left. Now we are saying that x is greater than equal to minus 7. That means from 7 everything right. Now this means and. This means and. So we have to do and operation. That means common between 2, right? So and really means common between the two. Intersection, right? Okay. So how do we get that part? That is to say, the solution is from minus 7 to 3. This is my part of solution. Right? So as an inequality, I could write the same thing as x is greater than equal to minus 7, but less than equal to 3. So this is the part. Now how do I write this in absolute function inequality form? That is a challenge. So one way here is to find the midpoint, right, and then get the answer. So the midpoint here is add them, divide by 2. So minus 7 plus 3 divided by 2, which is minus 4 divided by 2 or minus 2. So at minus 2 we have the midpoint. Now to write the absolute function, we have to see how far. So the second question is how far. Now these two questions will normally get you solution for absolute function. So what we notice here is that from 3 to minus 2 or from minus 7 to minus 2, it is 5 units, right? Minus 7 minus 2 is 5 units. This is also 5 units. So it is 5 units away when minus 2 is the center. And therefore, you get your solution. And the solution is what? You remove to minus 2. That means the absolute value of x plus 2. That means you're moving to this. Should be within 5 units. That means less than equal to 5. Do you get the idea? So this is the solution for part D. Correct? So that's how we solve. So for part A, we have absolute x greater than equal to 3. Here we have absolute value of x greater than any negative number. Here we have absolute value of x minus 1 is greater than 0. And in this case, what we got was absolute value of x plus 2 less than equal to 5. So I hope you find it very interesting. Let's move on and solve question number 3. Question number 3 is another interesting question on absolute functions. We need to sketch the graph of f of x equals to x cubed minus x absolute value and write it as a piecewise function. So what we are going to do here is that we'll first sketch the graph of a function. Let's call this g of x equal to the inside portion, which is x cubed minus x, right? So let's do that part first. Now this could be factored, so we could write this as x times x squared minus 1, so which could be written as x squared minus 1 is x plus 1 times x minus 1. So we have got 3 zeros, plus minus 1 and 0. So these are the 3 zeros, right? So we could just graph it like this. It's a cubic function, right? Symmetric about origin. It'll look like this. Perfect. So that's the graph for g of x. So let me say g of x here. So this is the graph for g of x. Now we need f of x. So f of x basically is the absolute value of g of x, shown in green. Now absolute value means it has to be always greater than equal to 0, right? So basically what happens is that the part which is positive remains as positive. That means this is same, correct? This part remains same. So this part remains same as the inside part. However, the part which was negative reflects. So let me reflect this. So it becomes kind of like this. Do you see that? And this reflects. Think that x-axis is a mirror, so it comes like this. Now that becomes f of x. So I hope the concept is clear. So this is the graph of f of x. Let's label it a bit. We'll call this minus 1, 0, and plus 1. Okay. Now, how do we write this as a piecewise function? That's the next part. as seen from here, we could write f of x as equal to, basically there are four pieces into this, right? There are four pieces. Clearly, one piece is when x is, we can say, less than. So with less than, we'll use just less than sign, minus 1. The other one is when x is between minus 1 and 0. So between minus 1 and 0. So that portion, let's use equal to with this portion. Okay. And then what we have is between 0 to 1. So between 0 to 1. Okay. And then what we have is when x is greater than equal to 1. Okay. So these are the four different pieces. What do you observe? You observe that in the first portion, it is negative of g of x. So I could write this as negative of x cubed minus x. In the second portion, it is exactly same as g of x. So it is same of g of x. And then it is reflected, correct, on the x-axis again. So it is again negative of x cubed minus x. And in the last portion, it overlaps. So it should be written as x cubed minus x. So that becomes the piecewise function of f of x. So I hope this concept is clear. So any absolute function could be seen as a combination of few pieces which are joined together at their zeros, as seen here in this particular graph. So it's a huge concept, and I hope that helps you to understand how to solve most of the absolute function equations and inequalities. Let's move on and take up the next question, which is based on inequality. Now let us try to understand how to solve inequalities where absolute functions are involved. So this time I'm going to give you purely algebraic approach. Now we'll begin by defining our absolute function. Now in our case, the absolute function is absolute value of 2x minus 1. Now this could be defined as negative of 2x minus 1 or positive of 2x minus 1, depending on which region we are working with. So we have to look for inside function. Inside function is positive for x greater than half. We'll say equal to also, but is negative for less than half. Since absolute function is always positive, we reverse it, right? So that's how you define. Now that clearly indicates that any question related to absolute functions should be solved into two cases. So case 1 will be when the function is on the left side or kind of negative, and the other one when the function is positive, right? It's the inside function I'm talking about, right? So in this particular case, x less than half and x greater than equal to half is that interval which we are talking about. Now, in this interval, when x is less than half, the inside function have to become negative because negative values will be negative to make positive. So the inequality changes to what? It becomes x plus 2 greater than equal to negative of this value. You get an idea. But when x is greater than equal to half, then absolute value of 2x minus 1 is positive value of 2x minus 1. So we could write this as x plus 2 greater than equal to 2x minus 1. Now this is the most critical step. So I hope this is absolutely clear, right? Okay. Now it is simpler. It's just a matter of bringing x's together and solving it. So let's open the bracket. What we get here is x plus 2 greater than or equal to minus 2x plus 1. Bring this minus 2x to the left side. So it becomes 2x, and we already have x here, greater than or equal to, we have 1 minus 2. And 3x is greater than or equal to 1 minus 2 is minus 1. And so x is greater than or equal to minus 1 over 3. Now that is not really a solution. We need to still work on that this greater than or equal to minus 3 should be within this interval. So let me draw a number line here, right? So this is a huge number line where this is the center 0 for us, okay? Now let's take the 2 points which are half. So let's say this is half for us, okay? So this is half for us. Okay. So half means this side. We are talking about that portion, right? And we are saying that the solution is that x is greater than or equal to minus 1 over 3. It really means what? It means if this point here is minus 1 over 3, then the solution is everything including this point to the right. So what is common between the two? The interval which is common between the two is from minus 1 over 3 to half, correct? So we get a solution here, and the solution is that x is between minus 1 over 3 to half. Correct? Now, since half is not included, will not include it. Does make sense to you? So the solution is this portion. This is not included, but that is included. So that becomes the solution. Do you get the idea? Correct? So from here, we say that x belongs to minus 1 over 3 to half. Perfect? Now you need to solve the right side to get a complete solution. So here, let's bring x to the right side. Since I don't want to make it negative, or let's bring it to this side. Okay, we'll do as we did here. Bringing minus 2x and taking plus 2 that side, we get this, which is minus x is greater than or equal to minus 3. Now we are interested in x, so we'll multiply with negative sign. So that becomes x, this becomes 3, and the sign reverses. That becomes the solution, correct? So that really means that we are looking for a solution which is on the left side of the given line, right? Which is at 3. So let's say this is 3 for us. Okay, let's say this is 3 for us. So the solution is everything including 3 towards the left. Now what is common? Well, clearly we are including greater than or equal to half. That means we are including this point and then moving up to 3, including 3. So that is the common portion. Does make sense to you? So from here we get that the interval is from half to 3. Now we have to combine these two since it is this or that. Do you see that part? So we get our final answer. And the final answer is between minus 1 over 3 to 3. Correct? So we get our solution, which is, we can write here as answer, as between minus 1 over 3 to 3. Correct? So that is how we are going to solve such a question. You can actually test your answer. 0 is a part of solution. If I substitute 0 here, I get 2 greater than 1. Does make sense to you, right? So you could check. If I substitute 3 here, 3 plus 2 is 5. 6 minus 1 is also 5. It is equal. So it works. So that is how you could also check your answer. Now let's do our bonus question, question number 5. Question number 5. Solve the inequality absolute value of x squared minus 5 less than equal to 4. I'd like you to pause the video, answer this question, and then look into my suggestions. Now, in the last example, we did how to solve the equation using algebra. Now here, I will visualize the solution using a graph and then get the solution, right? So the idea is to visualize. First, right? So this is extremely effective approach. So let's do it. So what we are going to do here is that we'll actually work on this particular function, which is x squared minus 5. As you know, x squared minus 5 will be kind of like this, correct? Where this portion here, vertex, is minus 5, and these zeros will be at minus square root 5 and plus square root 5, correct? Now, so this is the function which is x squared minus 5. Okay. But what are we interested in? We are interested in absolute value of x squared minus 5. So what is absolute value of x squared minus 5? It has to be positive, right? So it has to be this portion which is positive and will actually reflect this portion. Is it okay? So it will be this portion. Does it make sense to you? Right? So that becomes the value for x squared minus 5 absolute value. So the whole thing here is shown in this blue. Now what is 4? 4 will be a horizontal line. So this line here is y equals to 4. I'm sorry, y equals to 4, correct? Now when I say that, let me write this in orange. Okay, so when I say that 4 is greater than the absolute function, it means we are interested in this portion. 4 is greater only in this interval and also equal, right? So that's the interval, correct? And that's the interval. So this is the part of solution. Is that okay? Very even, correct? So that's the part of solution. So once you visualize, it becomes very simple. So what I could do here is basically find these points of intersections which are with 4 and the outside function, that is x squared minus 5 equals to 4. So I get those points, correct? And the second part here is that I could also find solution of minus of this with 4. You get an idea, right? So this is reflection. So the other part is negative of x squared minus 5 equal to 4. So we'll find these points. Does it make sense to you? So let's find these points. So for the first one, it becomes x squared equals to 4 plus 5. So x equals to square root of 9. And when you do square root, you do plus and minus. So what you get here is that x equals to plus minus 3. So these points are minus 3 and plus 3. Perfect. Now let's look here. So minus, let me take this as minus 4, okay. So we could write this as x squared minus 5 equal to minus 4. Bring 5 this side. X squared equals to minus 4 plus 5, which is just 1. So x is equals to plus minus 1. So these points here are at minus 1 and plus 1. So what is the solution? Clearly, the solution is that x is in between -3 and -1, or which means union 1 and 3. Do you see the solution? So we have solved inequality by our understanding of the equation itself along with the graph. So if you do this combination of graph and algebra, you actually land up with a very small solution. Otherwise, it could have been very complicated. So I hope this point is absolutely clear. So with that, we come to an end on some interesting questions where absolute functions are involved. Let me again thank some of my viewers who have been posting these questions for a long time. And I hope all of them have got some solutions. Feel free to write your comments and keep posting questions. Thanks for watching and all the best. If you really like and subscribe to my videos, that'd be great. Thank you once again.